and welcome to today's session. Which is the Demystifying AI, a practical guide to common AI terms. And just to introduce myself, for those that do not know me, my name is Benjamin Busari, and I will be serving as the host and moderator for today's session. So today's just to also like shed a bit of light for some of us that maybe just joining one of our sessions, right? So we are a Microsoft multi-Microsoft AI user group community, and the community is aimed at fostering knowledge for both either you are an AI enthusiast, cloud enthusiast, or you're already even a business professional looking to increase capacity and knowledge also to around the aspect of AI, cloud engineering, DevOps. So whether you're just beginning your AI journey or you've encountered terms like LLMs, embeddings, RAGs, or AI agents, and you're wondering what exactly do all of this actually mean? So, courtesy of the community, this session is designed to simplify those concepts into practical, relatable explanations for everyone on the call. And we're excited, as you can see, to have a speaker with us today. So the speaker will be helping us to navigate this topic and show us also to how these technologies are shaping the future of how we work and also innovation. So please feel free to drop your questions in the chat, as the session goes on. We would also, if time permits, have a dedicated Q&A segment towards the end. But if something isn't clear, please feel free to drop your questions in the chat section. But before I introduce the speaker, just to also bring us up to date with some of our upcoming events, if you're not aware, we have the Microsoft Build Localhost program coming up 24th of June. That's like next week. So I'll drop the link shortly in the chat area also too. So please, for as many of us that have not registered to, be a part of that event, please do well to click on the link to register. We also have some upcoming events also too, scheduled for the respective months other than even June. We have events spanning to September. So please feel free to click on the links, check out all the different events and try as much as possible to register so you can be a part of the event. And we're also, available on YouTube. So for past events and even this one we're having today, you can also click on, check us out on YouTube to also access the recordings for all of the different events. And of course, other events and activities that we do within the community, we post across our social media platforms. We're on Facebook. We're also on LinkedIn. So please, all these links that all this part of what I talked about, I will be sharing the links shortly in the chat area. So please keep your eye on it. You can also click through and make sure to sign up. So it is my pleasure to introduce our speaker today. Our speaker, whose name is Olawale Bello. He's a skilled Microsoft Azure professional, and he has worked in various roles since 2018. Roles including deployment manager, roles including the Azure solution architect, and he has a solid background in designing and delivering cloud solutions. So we are set to experience quite a lot of, um, experience around the aspect of AI, because this is someone that has gained deep knowledge of the Azure ecosystem, as well as is someone passionate about AI and is focusing on using, modern AI technologies to address real business challenges. So I'll introduce our speaker now, and then yield the floor to him. So hello, Olawale. You have the floor. Please go ahead.
All right. Thank you, Benjamin, for the warm introduction. So without any further ado, I will share my screen quickly so that we can start this section properly. A moment. Okay, trying to. A moment, I'm trying to. Let me try to the video. Okay, it's responding now. So kindly screen.
Sorry, not sure I can hear you. No. No, still can't hear you. No, still the same thing. Still can't hear you. So I think you're having challenges with your audio. No, still the same. So your screen is not up and we also can't hear you.
Sorry, Olawale, can you disconnect the headset? Maybe probably speak directly to your system speaker. Can you hear me, everyone? Ben, can you hear me?
Yes, loud and clear. I think Olawale
Yeah,
is
we can
perhaps
hear
having
you.
issues. Yeah.
So, Olawale, please, can you disconnect your headset completely and just use the normal computer speaker? Apologies for the inconvenience.
Still can't hear you. Do you perhaps maybe want to leave the call and rejoin again? Possible? So if you're speaking,
Better.
yeah.
So everyone, let's keep us engaged. Depending when the speaker is back. Ben, can you come up? So based on what we are about to discuss, which is about demystifying the AI terms, we all know that AI is trending, and then we all are learning, even the high and mighty in the tech industry try to build up skills to be better in the AI era. So that is exactly what we are trying to do. And the best way to learn is getting your question ready and to be asked to be asked to the speaker, and then contributing during the section, making it lively and all that. So we can keep the session going. I wouldn't want us to be just quiet, leaving the speaker alone speaking. Not that we need to interrupt the speaker, but at least drop your questions and then contribution. Those are the ways we can really keep the session going. Apologies once again for this technical glitch on the speaker side. He is going to be back shortly. And
Okay, all right, awesome. Thank you, Imo, for that. So just once again, just like Imo said, let's just keep the chat going, right? But before the speaker comes on board, again, just let's do a quick AI experience level check, right? So maybe just with a reaction, a thumbs up, or maybe a chat in the section. Let's look at an instance where, let's say, for instance, which best describes you in a part where are you completely new to AI? Do you use AI tools like ChatGPT occasionally? Are you familiar with Claude, Vertex AI? Do you use Kira? So if you're within this particular region of if you're completely new to AI, can we see like a show of hands or chats just to be sure that we are all on this call and we are live? Can everyone hear me? Right. Thank you, David. Right. So completely new to AI. Any other person? I see reaction from Marka. Thank you. So completely new to AI. Okay, great. So if you fall in within the section of we use ChatGPT or MT5 Copilot, GitHub Copilot, any of the Copilot tools, can we also see reactions? Or maybe people just joining the call and do not maybe just get into AI and do not know what Copilot is. So in layman terms, you just have Copilot as an AI assistant, right? So assisting you with your either the aspect of what you do with ChatGPT, where you send in a message, you get a response, you're able to draft documents, maybe PowerPoint presentations with MT5 Copilot, or even get intelligent recap summaries, right? Doing meetings with the MT5 Copilot. So how many of us use any of these tools? Okay, all right, great. So I build AI solutions to conduct AI research. Can we get reactions? How many of us has moved beyond being just AI enthusiasts into building AI solutions? Oh wow, yeah, thanks. Okay. Any other person? I mean, we're about how many on the call? We're 18 on the call, just one? Oh, Kessa, thank you. Thank you for that. All right, so maybe let's do this right in the chat section. When you hear the term AI, artificial intelligence, what is the first word that comes to mind? Can we maybe put that into the section? I mean, some would say AI is, innovation. Some would say robots. Some would say AI is scary. So what comes to mind when you hear AI? Could be from a definition perspective, or it could also be from a usage perspective or how you perceive AI to be. I'm checking the chats, but I can't see anything yet. Nothing comes to mind when you think of AI? Yeah, I can see David is typing. Like an encyclopedia. Good. Am I getting more? Great. Yeah, faster implementation. A machine thinking and doing things like a human. Yeah, also scary. Exactly. Yeah, it's scary. I mean, perhaps if we are conversant, we would have heard about the Mythos and the Fable 5, right? That got released and also got disabled almost immediately. So, systems that make complex tasks easy, correct. Let's keep it coming. Also to make tax. Yes, correct. And we're actually all correct in that regard. So, and you would agree with me that today, AI, artificial intelligence, has become one of those, most talked about technologies in the world today. So whether you're in healthcare, you're in finance, education, engineering, customer service, or even the creative industries. For some of us that have heard terms like LLM, and for some of us that have not, that have heard it but do not really know what LLMs are. So you have, things like large language models, you have things like generative AI. Today you have what you call AI agents. Either you have it as task-based, or you have simple AI agent, or you also have the cases of autonomous agent also too. Then you also have RAG, right? I mean, I think my first time coming across the word RAG, I was kind of confused. Some would say RAG, some would say DAG. What's the difference between the two? So RAG is just the retrieval augmented generation. You have fine-tuning also too as common AI terms, and these are things that will be discussed during the call today once we have the speaker back on. But one thing, I mean, sharing from my experience that I would say is, I mean, I am an AI engineer, right? So I don't just use AI, I also build AI solutions. And if I am to be honest, I would say many of these terms can sometimes be intimidating or sometimes be confusing, right? But one thing I've also come to realize is that the challenge isn't that AI is, let me say, inaccessible. It's kind of like the language that surrounds it often that makes it more complicated than how it actually is. And you would agree with me today also too that with the part of AI, okay, great. I
Hello,
think we
can you
have
hear me now?
awesome. Yes, we can hear you loud and clear. So we have our
I'm
speaker back
very,
on now. Apologies
I'm
once again
very,
for the delay. So yeah,
I'm
let's
very
get right into
sorry
it.
about, I'm very sorry about this. The system just start acting up immediately before we start the section. So permit me to just switch off my camera, probably in order not to experience any challenge and all that. So let me quickly switch to presentation mode. So good afternoon, everyone. And thank you once again for your time and for joining the section organized by Mota Microsoft AI group. Once again, I'm sorry about some delay. It is caused by the system. So let me quickly go to the next slide. So like the moderator introduced me earlier, my name is Olawale Bello. So I've been in the technology space for more than a decade and in the cloud as well. So I've interchanged from different roles in the AI space, working from a deployment architect to solution architect to different roles which I've interchanged in the course of my journey in the AI and in the cloud in general. So Oh, sorry, I think I shared different slide. A moment, please. Oh, sure. This is what caused by when you have already prepared to, and the system is acting up. Let me quickly check the. I think I should have it in. All right. I have the right slide now. Kindly confirm when you can see the slide.
Yes, so I can see your screen, and I'm sure
Okay.
that's
Can see
also
your slide.
All right, thank you. Without any further delay, so at the agenda today, the agenda for today's section, we before we dive deep into discussing the commonly used AI term, it makes more sense to briefly discuss the history of AI, how AI started to where we are today in the AI space. Then we move on to also discuss about the different type of the categories of AI, from generative AI to non-generative AI. Then we dive deep into the core course of today's section, which is discussing the commonly used AI terms. And then we discuss also about the AI application, how AI application work. So brief history of artificial intelligence. So artificial intelligence AI did not just appear overnight. Um, it evolved over more than 70 years now, moving from a simple idea about whether machine can think to becoming a technology used by billions of users in every day. So AI journey began in 1950 when British mathematician Alan Turing asked a simple question about can machine think. He introduced the tuning test, a way of checking whether a machine could behave like a human being in a conversation. And in 1956, the artificial intelligence AI was originally created at a conference organized by John McCarthy. Researchers believe human-like AI could achieve within few years. However, between 1970s and 1980, early AI progress was slower than expected. During this period, all AI focused on expert system kind of. The expert system used predefined set of rules, like kind of programming, kind of to ensure that the prediction from AI experts to decision making. Examples are like um, uh, medical diagnosis, uh, geographical analysis, and chess playing. The system were useful, but major limitation is that they could not learn or adapt on their own. So in 1990s, the focus shifted from teaching computer to teaching computer how to learn from data. The approach became known as machine learning. A major milestone occurred in 1997 when IBM's Deep Blue defeated the world chess champion Gary. For the first time, a machine beat the world best human player in chess. So in 2010s, AI experienced a major breakthrough due to three major factors. Number one is more data, the availability of huge amount of data. that AI can learn from, or that we can use to teach AI. And the other factor that make that breakthrough in 2010 is computer GPU, which is kind of the computer chips that is used to ensure that AI model that we use today can learn very fast, and through which the technology that was used to ensure that generative AI become everyday use for everybody. In 2012, a system called AlexNet drastically involved image recognition and demonstrated the power of deep learning. AI quickly become better at recognizing images, understanding speech, and playing complex game. Then the technology company began to invest heavily in AI. So from 2017 to the present, researchers introduced what is called transformer architecture through a paperwork called Attention is All You Need. Transformer become the foundation for modern AI system. This transformer architecture leads to the creation of model like GPT, Claude, and Gemini that powers most AI application or AI tools that we use today. In late 2022, OpenAI releases ChatGPT, making AI accessible to everyone in the world. From then, AI could now hold conversation, AI can write documents, generate images, create code, and answer questions. This marked the beginning of generative AI. So moving on. So like what I discussed earlier. So these are the milestones that we've experienced from AI involvement from tuning tests, the British mathematician that asked a question about can AI think, to the machine learning era, to the deep learning era, to the transformer era, and to the era that we have today, that everybody can now leverage the power of AI on their mobile, on their laptop, and the like. So the next one will be to discuss the difference between two major categories of AI, which is generative AI and non-generative AI. So when we're talking about non-generative AI, non-generative AI are kind of AI that can analyze, classify, predict, and also recommend. This AI, the AI that empower so many tools that we use that we probably don't know about it, like fraud detection. Bank users or bank itself leverage the system to flag any kind of suspicious transaction, like probably someone is using the transactions that someone was about to happen is strange to the kind of the transaction that someone already kind of used to, or whatever the transaction that the person is trying to achieve. Say, for instance, someone has never, in the history of the transaction that this particular person, this particular user that wants to try to implement, he has never done such a kind of transaction before. The fraud detection system will flag that, and we kind of alerting the system, the bank, and the bank user. One of other generative AI system is spam detection of email spam filtering. This helps us to classify email as spam or as legit, and also the recommendation system, which also help us to suggest movies. Like if someone usually kind of used to watch an action film, or someone that used to have an historical film, based on the kind of the film or movie that this particular person watched, the recommendation system is behind what is recommending a particular movie to someone. And also, part of the non-generative AI is weather forecasting system that can predict if it's going to be rainy or stuff like that. And from there to other kind of non-generative AI like image classification and voice recognition as well. So the next one under the categories of AI is generative AI, which many of us leverage today that actually bring AI to many of us to use, because the non-generative AI are kind of system that company uses more, unlike individual, many of us that use generative AI. And what is the main difference between generative AI and non-generative AI is that generative AI itself can create new things. Why non-generative AI cannot create new things? It's based on the task that it is designed to perform, compared to generative AI that can create new things like text, images. It can create code. It can create audio. We use generative AI to create video and many other things that we can use generative AI to do. So the main comparison or difference between the generative AI or non-generative AI, and again, non-generative AI is also called traditional AI. So the main difference between the two or the feature is that I will be talking to on this slide, because of the time that we've wasted already. So I will not be taking us through all these comparison one by one, but one of the main focus of this comparison is the primary purpose. Traditional AI, which is also non-generative AI, is designed to identify, classify, predict, and recommend, while generative AI can create new things. It can create new content, it can create new text, it can create images, audio, and video. And the strength comparison of the two is that the non-generative AI, which is traditional AI, is fast, precise, and reliable, while generative AI can create is flexible and versatile. And before leaving this, it is very important to also mention the limitation of the two. So the traditional AI, it is narrow in scope. Narrow in scope means that it asks what it can do, why the limitation of generative AI, because it's versatile, it can be creative, and it is flexible, it can be hallucinate. Hallucination is one of the AI terms that we will also discuss in the course of this section. Hallucination means that when AI can give a response, incorrect response confidently. But we still get to talk more about that AI terminology. So the next one is the actual primary objective of today's call, which is tries to demystify some commonly AI used term. So what I've done because I have like 50 plus AI terminology to discuss today. And what I've done is to kind of categorize them or group them into concepts in order to help us achieve more about this section, in order not to confuse us more, just to make us understand this commonly used AI term. So the first concept is foundational concepts. So in this foundational concepts, I just to ask, I hope I'm not too fast. Because we've wasted a lot of time, so I'm trying to can someone confirm if I'm not too fast so that I can reduce my pace?
Yes, thank you. Yeah, I'm sure the audience are following.
Okay, because I'm trying to make sure that we can cover as much as possible. We've wasted a lot of time already. So the foundational concept, like I mentioned, I try to group all these AI commonly used term into concept, just to ensure that we can understand. And one very important thing that I would like to say here is that I will not be defining this concept, rather I will be describing it, because defining it using AI professional definition or data scientist definition can even cause more confusion. However, so what I think it is best is to describe rather than to define. So when we're under this foundational concept, I have 4 commonly AI used terms here, and I will kind of describe them together rather than to pick them one by one in order to help us understand it. So first off, the artificial intelligence itself. We've talked about the history of artificial intelligence, and we've talked about the 2 category of artificial intelligence, which is generative and non-generative. But the artificial intelligence itself, what is the primary purpose? What is the kind of, if you want to define it, it is a broad field within computer science that is focused in building systems that can perform tasks that would normally require human intelligence. It is a field within computer science that is designed or that is focused to build system that can perform tasks that will require human intelligence. Some of those tasks is reasoning, learning, language understanding, perception, and problem solving. Human being can do all these things. So we're thinking about how machine or a computer or a system, because I'll be using those words interchangeably, machine, computer, system. How can it also perform the task that would normally require human intelligence, like mentioned reasoning, listening, language understanding, problem solving, perception, and the like? So that is AI. But when we're talking about machine learning, deep learning, and neural network. So machine learning, first off, it's a subset of AI system, right? Deep learning is a type of machine learning. But what is machine learning? What is deep learning? So machine learning, it is a method or a way of teaching computer or which computer use to learn from data. Deep learning also is a way or method of teaching computer or which computer use to learn from data. But what is the difference between the 2 of them? Because they serve the same purpose. So the difference between machine learning and deep learning is that machine learning, when we are building a system and the amount of data available to train the system or the machine, or amount of data that the machine wants to learn from is minimal and simple, then the machine learning method or is leveraged to teach the system that AI focused in building that I mentioned earlier when I was talking about the purpose of or the definition of AI. But the deep learning, on the other hand, is leveraged to use to build to ensure that the machine learns from data when the data is complex and huge. So that is the main difference between machine learning and deep learning. The main difference, there are a lot of differences and a lot of things that we can discuss, but in order not to make it simple and to just make it at a starting off for people that's just going into the AI, some experts in the building understand more, but in order not to confuse people that are just starting off, so I will just stop there just to make it easy. Machine learning is a way, and deep learning and machine is a way of teaching computer and a way of where computer learns. Think of it like a child that doesn't understand the language yet. It doesn't know how to walk yet. It doesn't know anything. A newborn child, and we want to kind of train this child, or the child wants to learn from us. What is the technique that we are using to ensure that the child is learning? So this is the machine learning. Machine here is like system, AI itself, and the way the child is learning. And the other difference between machine learning and deep learning is that machine learning use a neural network, which is the other AI terminology under this foundational course. So neural network, see neural network as, if I want to elaborate more about neural network, I'll be saying that, okay, it simulates human brain, and it has a multi-layer connected that is used to perform all these tasks. It has input layer, it has output layer, and in between input and output layer, there are multiple hidden layers in which, when the data is feeding into it means a system we wants to build, and the data that wants to use to train the system that we are building get into the neural network via the input layer, and then from the middle layer between the input and output, the multiple hidden layer perform all the dirty works and all that. But let's not speak more jargons while we are trying to demystify jargon already. So to break this further down, neutral network, assuming neutral network is like a learning engine. In human being, when we want to learn, what we can identify as our learning engine is our brain. We have different parts of the body. We have leg, we have hand, we have everything. So when we are learning, there are different parts of our body that we can use to learn. We can use our eyes to learn based on what we see. However, the major focus, the major engine to learn is the brain. So see, neural networks is the engine, the brain that AI wants to use to learn. Deep and machine learning are the method that AI wants to leverage to learn, or that wants to use to teach AI. So moving on to the next one under the foundation concepts. Here I mentioned LLM, but let's just first of all get our attention out of the large already. Let's get our attention out of this large language. Let's just focus on the model first off. So the model is like a brain for any artificial intelligence. That is actually what the output of the training that we are training, the training that I mentioned earlier. The AI is leveraging different methods like machine learning, deep learning, using the neural network technology architecture to ensure that all this learning possible. The outcome is the model. So here I just mentioned only large language model, which is a model that is trained on a billion of word of text, even trillion sometimes, for AI to perform optimally. But like I mentioned, if we get our attention out of this large language model first, let's say model, because every other system that I've mentioned earlier, like fall under the non generative AI, which is traditional AI for prediction, analysis, and recommendation, they also leverage model. But the type of model that they leverage is different. Like fraud detection leverage fraud detection model. The email spam filtering leverage spam filtering or spam detection model, and the weather forecasting model also leverage. So all of this system leverage model that act like a brain for them. But because I'm talking about the text or the language model, that is why you see this language model on the screen. And other, when you also look under the category of generative AI, where AI can create new content, like can create text, it can create audio, it can create video, and all that. All these, each task also has a model that can perform image generation, that can perform audio generation. And again, we also have a model which is called multimodal that can perform multiple tasks like text, image, and audio generation. But sticking to this particular one, I hope that is understandable that we have different model, not just a language model. Each task that we want AI to perform as a model that can perform that task. So when we are talking a large language model, is the model that the tests that make the test generation side of generative AI possible. An example is like Copilot, ChatGPT. ChatGPT is a model that GPT-4 or GPT-5 or any version of GPT is the model that the ChatGPT leverage to answer our questions. When we use Gemini, is the model that the Google use to provide the response to our questions. And moving on, the foundation model. The foundation model is the model that is pre-trained already to serve as a basis for many scenarios. It is trained once, and that model can be leveraged to serve different purposes that we want to use to serve. Just think of it like an operating system on a computer. Be it maybe Windows operating system, maybe Mac on the Mac PC or Linux. It is the foundation on which many applications can run. So that is kind of foundation model. It is pre-trained with a massive data, and it can serve as a basis to whatever scenario we want to use the AI for. Like language model, it is trained on a massive data to be able to provide response and summarizing and make sure that the output that's given is structured in a woman readable and very structure. So the transformer. So the transformer in the course of this call, we explain transformer more. Transformer is actually the technology that make the deep learning possible, and that is the architecture that was used to build many of the model that we're using today. But the flow of the transformer is that when an input token, and token is also one of the AI terms that I will be discussing today. But just see like the test, the questions, the input token is just the questions that you are asking AI. Think of it like the user ChatGPT or Copilot that you use, where you just ask a question, and from there, the LLM, which is large language model, processes and generate output, which is the response that we get whenever we leverage any of these AI tools. So the next concept is prompting. The prompting is how we communicate with AI. So the prompt, when you hear the word prompt, it might be strange to people that are not AI savvy, but some experts in the building also already understand. So the prompt is just the text or the message or the questions that is typed on AI tool. That, okay, what is the capital of England? That we can type on Copilot or we can type on ChatGPT. That is the prompt. And the prompt engineering, in the other hand, is just the act of the act of crafting the prompt, being creative with the prompt, because it's a kind of simple. Can I use it as simple or kind of prompt that's a weak prompt can bring a weak response as well. So when the prompt is very okay, then the response also will be very okay. So, and the context window in the other hand is the amount of text that AI can see at once. When we are chatting with AI with ChatGPT, the amount of text that the AI can see at once, it is like a short-term memory for AI, because AI normally cannot remember what we discussed before. Maybe the test we sent earlier, maybe when we send a test, what is the capital of England? And we ask another question as a follow-up questions. Without the working memory, AI does not remember, but the context window is amount of text rather, that the AI can process or can see at once. And completion is the response that AI give back to the prompt that we give to the AI. Actually, to explain this temperature, I want to bring up something to explain temperature more, although we don't have much time. But even at that, I think it's better to cover as much as we can cover and get best out of it than to just because of the time and we don't do what we're supposed to do. Let me know if you can see my screen where you can see transformer explain. Can you see that?
Yes, Lawale, we can.
All right. Okay, so to explain
Yes,
the temperature, temperature is like kind of control to determine, to tell AI how creative or predictive AI can be. So to explain it, I will use this to understand it. Normally, this generate button is supposed to work, but because I think something happened, I couldn't finish the download of this GPT-2 model that will make it work. But let's forget about that. So this temperature, and I can see this temperature, and I set to 0.8. 0.8 means that if this generate button is working, if I click on it, see this example, data visualization empower user to visualize. The next token, which is the next word, if I okay, I think it's working now. All right. So if I click on the next one, so it will go to the next available data. On this, if you look at it, it says data visualization empower user to visualize data. But this, what you can see here, if you can see, and the next one, you can see all this one also depending on the sampling data, which is top K and top P. So because I said temperature is to control how creative or how predictive AI can be. If I bring it back to 0, you will see here that the creativities of AI, the lower it is, the lower the creativities of the AI on its response. Okay, the top K also determine the multiple choice available for AI to choose. The top K now is set to 5. See, it's like when a student is writing an exam and it is given a question, an option that he can choose from. Top K is the kind of option that's available to AI to choose from. Because it's 5, that is why you can see, if you look here, 1, 2, this one has some percentage applied to it. This one also has some percentage, this one has some percentage, and this one, and this one. From here down, there's no more with any percentage again, because it's set to 5. If I reduce this to these choices that AI has access to choose from, then the number of choice will be reduced as well. You can see now that because I reduced to 1, the only option that AI has left is just this one. If I increase it to more than, say like 12, if you look at this, all these other words have a percentage attached to them. So the more I just try to generate, the more it can choose from the available option. That is the temperature and the sampling data, which is top K. Top P is also a part of it. It's the probability. Top P is the probability of, if I choose to top P now instead of top K, you can see that the probability of taking this one is 100%. The probability of the choice that is taken from is 100%. So moving on, let me, because I can see that time is fast spending. So that's temperature. And like I mentioned earlier, hallucination is when AI is providing incorrect response confidently. So let's move on to messaging and chat concept. So messaging and chat concept kind of want to speak to the same thing from prompting, but I will explain briefly. So system message is kind of instruction that define the behaviors of AI. If you want AI to be a soldier, from the system message, the system message is the one that define that behavior that you are a soldier, and AI will act like a soldier. That is the system message. This is not feasible to all of us AI user. It's feasible for AI developer. Before the AI is put out there for people to use, the owner of the AI or the developer of the AI already put some instruction in place for AI to define the ability, the capability, the behaviors of the AI. So now, the user message and assistant message. The user message and assistant message are kind of when you are saying prompt and completion. Prompt, the message that you type to AI, user message, and assistant message like a response you get back. But why it is different, or why different terms using at the same time for the same purpose? So that difference. So let me explain the assistant message, then come back to the user. So the assistant message is which I say that also kind of, if you can recall the slide before this one where I mentioned completion is the word used for response that you get from AI. So why is the assistant message is different from completion is that the completion is kind of a raw data from the model, from LLM, from the model itself. Why assistant message is kind of structure, formatted, user-friendly that users see. So the completion is at the prompt level, at the model level. As it's coming, the formatted one, the structured one is the assistant message. So you can see people using this term interchangeably, like maybe completion or assistant message. Previously, before this era, what you will be hearing much is prompt completion, but in the recent time, you start hearing user message and assistant message. User message different from user message, and the prompt is a single message that you ask. Why the user message comprises of the question you ask, the user message, the instruction, like the user message, and the any kind of data, any kind of assistant data that it can use that AI can leverage, information that AI can leverage to get better in the response that it's providing. And the conversation history and the memory, like I mentioned earlier, the memory is just the conversation history, like when you ask first question from the AI and AI provides a response, you ask another question, like a follow-up question, to get more clarity on the response that you gave. It responds back. You ask again. All this converse back and forth conversation are the conversation history, which AI is also used as a memory to track the discussion that has been going on between the user and the AI. So next one, because I think it is time and I'm getting some conversation about just to manage time. So let me quickly also explain this part briefly. So the data set. So I will be using a kind of library to explain the data set. So data set is kind of a library where we have many books. Training data is a book that is a student study. In the library, you have hundreds of books. And the training data is the book that a user read from the hundreds of books in the library. So like in the data set, when we want to train AI, we could have maybe 100 billions of data. And the one we use actually that we use to train data could be maybe just 90 billion of that 100 billion of data. That is the training data that AI learned from, or that we use to train the AI. So fine-tuning terms, when you hear fine-tuning, and like I mentioned earlier, I mentioned foundation model that is pre-trained to serve basis for any scenario. So when we are not talking of fine-tuning is that you have this model that is been pre-trained, to serve general purpose, right? But you want the model, the AI, to serve a specific model, and you have a specific data that you can make AI serve that specific purpose. Then we use that specific data to build or improve the pre-built AI. So that is fine-tuning. So say for instance, it's a lawyer that's already trained as a lawyer, but he wants to become maybe you want to be specialized on tax lawyer. So you can just do a kind of 3 or 6 months to quickly brush up and be specific on that aspect. So the token, like I mentioned earlier, the word that we send to AI is converted into token. Converted into token, and the token is how the AI developer or the owner of the AI bill the user. So if we are talking about the token, so just to help us understand the token, so let me just bring this out just to help us understand how the token works. So AI does not see our message that we are sending like the way we send it. It first tokenize it, convert it into token, the smallest unit of the text. So if I paste this one that I copy here, if you see, this is how AI did it. If I put this to AI, like I type this on the AI, this is what I'm seeing. This is how AI is seeing it. AI will first of all change it. So this one, if you count it one by word, if you put this one on the Microsoft Word, it will tell us how many words is this. But this is what AI is seeing. Everything is counted. If the full stop, the question mark, everything, the space is counted as a token by AI. If I remove this, like you can see this is 86 token, and this is what AI provider used to build us. If I remove the last dot on this message now, the token will reduce to 85. Everything is counted. And this is what AI owner or the provider used to build us. It's just like when we're making a call that we are being charged based on per minute or per seconds. And embedding, before talking about embedding, I'll first of all talk about factorization. Factorization, because computer understand numbers. So factorization is a process of converting text. The text that we send to AI, like when I'm showing the other screen about tokenization. The factorization is AI first of all convert the word that we ask to token, then convert it to the number that the computer can understand. So factorization is nothing but the process of converting a text, image, or other kind of data that we use into embedding, which is into vector. So when we're now talking of embedding, we're talking of vector converting a number, a text or image to number. Embedding is now to attach a meaning, a numerical meaning to this word that has been converted into the number. Moderators, can we still continue, because can we still spend like a few minutes to discuss the other ones?
The time is fast spent already, but we can still
Accommodate like few minutes more.
Yes, please. So we can
All
just
right.
maybe fetch a round up in 5 minutes.
Because in 5 minutes, okay, let's see what we can achieve. I will try to be fast about it, but in the course of trying to fast, I hope I'm not too being fast, and people can still get a few things out of the section today. So we have what is called search and retrieval concept. So the best way to quickly go about this, to explain all these are the kind of search approach that we have, that AI can leverage. We have keyword search, we have semantic search, we have hybrid search, and we have similarity search. In order to summarize everything at work because of time, keyword search is just like when AI is looking into the data available to it, it's looking for exact match word. You are searching for maybe B, and when AI is looking for when this keyword search approach is leveraged, AI will look for any document that has that B and present it. That is a search match is the keyword. Semantic search is a scenario whereby AI does not AI is, if this semantic search is leveraged in the AI system, it does not look for the just keyword. It's looking for the meaning. Like example on this on this screen that I put here, when you say dog food, everybody understand that if they say puppy, you understand that it's dog. But computer is not like a human being. But in a scenario whereby semantic search is leveraged, when a search comes to AI that leverage semantic search approach, and you put puppy, it understand that puppy is also dog. Unlike keyword search, it does not understand that puppy is also dog because it will be looking for a search dog. Why the semantic search approach, if a user prompt a puppy, you understand that the meaning of the dog is also a puppy. And the hybrid search is an approach where it combines the keyword and the semantic search together. This is what most enterprises AI system leverage, and the similarity meaning that is similar to the one that we requested for in our prompt. So the RAG system, So to quickly explain this part, also the RAG is a scenario whereby AI does not. Let's say, for instance, let's say the workup is ongoing right now, right? And AI is the training data of the AI probably 2025, where the workup has not started. If we now ask AI about information about the workup, if AI wants to just leverage the information that he has already, it might not be able to give us any response. If it will not even able to give us any, it might not, because the data that was used to train, that he used to learn from, the workup is not there. So how organizations are leverage this RAG system is, if I want to know something about the company I'm working on, and I go to ChatGPT is not aware of our internal policy and stuff like that. So RAG system is a scenario whereby the organization information is leveraged. We put there are so many processes that are going on for RAG system to work, but we're not going through all those processes. But what I will say to explain is that when a user asks a question, like what is refund policy for my company, it might be different from your own company and every other company as well. So a semantic search or hybrid search is performed against the data in the database, which is peculiar to the company and organization. When that data, retrieved data, the retrieved data will now put together into the prompt to augment the prompt. That's why you see it first of all retrieve the information, it augment it. Augment it is just to take that content that you got, then add it to the question that user has and pass everything to the LLM. Then LLM then provide a response, generate an answer based on that. I plan to explain it more than this, but because of our time, I hope we can get something out of it. And the reason why we use RAG system is to solve the hallucination problem, because AI will provide an answer if conveniently, if it is not, even though it is not correct. But with the RAG system that's aware of the data that we're actually requesting for that, if we want to search for that ourselves, it might take us days or many hours rather. So storage and infrastructure. So the RAG system leverage the vector database. The vector database is a special database that stores and retrieves embedding vector. So So the knowledge base. So let me just explain this slide, and from this slide we can round up. We can round up anyway. So the knowledge base is the knowledge where the data, the information is stored. For the kind of library where we have all our as a data source, like maybe Word document, PDF, and other that AI can perform search on, and the program interface in the context of AI. So I won't explain it in the context of application and system development. In the context of AI, this model that we want to leverage, the AI power application that an organization is building only connect to the model that is hosting maybe in a cloud provider via API, because API is just like a way of making a software application to collaborate or communicate with each other. And cloud AI is kind of a pay-as-go service, because building and hosting AI solution on someone's environment is kind of very high impossibility, because it requires a very huge amount of infrastructure, and that is why cloud AI is kind of a service that you can pay and you use. GPU originally designed to provide graphic to people that play game. So it's hardware chips that AI used to build all this model. And inferencing is AI has been trained and the training has been cut off. It's just like, okay, let me use a student as an example. Let's say a student has been reading for maybe let's say semester start, and for like 3 months, a student has been reading. So during the exam, when the exam started, the student cannot read again, but to write exam. So inferencing is like the responses that AI started giving based on the knowledge as acquired in the past. Now we are want to using it. We are asking question. It's providing a response based on intelligence, based on the data it has learned from. That is inferencing. What AI is giving back, the cost of running AI day and day and day. So we'll be stopping here. Because of our time, there are still a couple of one that I plan to discuss, but because of the time is fast, as we've like 14 minutes ahead of the time. Sorry about that. That's my system start fucking up at the beginning of the section. So I'll be handing over to the moderator to conclude the section now.
All right, awesome. Thank you so much, Olawale, for that. I mean, I'm sure we have actually had a lot to learn, because even it has been sort of like a refresher for myself. And apologies once again to everyone for the overrun in time. So we had like a bit of technical glitch. So, but just for people that joined in late, the recording will be shared on YouTube. So please feel free to go on YouTube, subscribe to the channel, so you can actually have access to the recording. And for those also too within the WhatsApp channel, we would also be making available the slide, so you can always have a look at it and do further research on it. So as we come to the end of today's session, I would like to sincerely thank our speaker for the aspect of simplifying the concepts that I'm sure to most of us now has been quite enlightening, right? And we hope everyone here will be leaving today with clear understanding of those AI terminologies, from LLMs to RAG to tokens, even to temperature. And of course, we should have greater confidence now exploring this rapidly as we do more research. So thank you to everyone who participated. For those that engage through the session, please keep learning, keep experimenting, and continue the conversation beyond today. Also, please, once again, check the chat section to follow for updates on most of our events, future events coming up, our YouTube channel again, our LinkedIn, and also you can as well have insight into our code of conduct, right? So how do we, function as a community? So you want to also even be a part of some of these things that we do also too, please feel free to go through all of the different links. On this note, I would say thank you again to everyone for being a part of this session. Thank you to our speaker. Thank you to all the participants online. Do have a wonderful evening, and we look forward to seeing you at our future events. Thank you, everyone.
Thank you,
Thank you,
everyone, for
guys.
joining. Thank you for your time.
Thank you, everyone. Thank you so much.